Hello, let's see how FreeBSD 14.2 can run Docker-style container images. FreeBSD 14.2 now ships OCI container images, which are Docker-style container images. Let's see where these are located. In here, download.freebsd.org/releases/OCI-images. There's multiple architectures. We're interested in AMD 64. There's 3 images, starting from the smallest, going to the largest. The largest one contains the middle one and the smallest one. The middle one contains the smallest one. So static is a minimal part of the FreeBSD userland, not containing, of course, the FreeBSD kernel, which is just enough to run a statically compiled, for instance, C programming language executable, which can run on AMD 64 FreeBSD 14.2. The next one is dynamic, which allows you to run, for instance, a C++ programming language executable, which links to the standard C++ library and standard C library from FreeBSD. And then minimal is a very small FreeBSD userland that allows you to run what the previous containers allow, which is static built executables, dynamically built executables, but in addition, there's also a small Unix style userland. So there's ls and mount, sed, grep 1000 command line executables. Because the FreeBSD operating system has the FreeBSD kernel, you can natively run these containers in an alternative to Docker, which is called Podman. And then because the FreeBSD kernel plus the Linux emulation, which runs in kernel mode, you will also be able to run Linux style container images, such as this one, the Alpine Linux minimal Docker image. The technology containers on FreeBSD is still in progress. You should expect some things not to work perfectly. So let's see. The Docker software is a way to run, for instance, just a HTTPS server. For instance, Apache HTTPD or Nginx. So a single application, you run it inside of a very restricted environment similar to a chroot or to a FreeBSD jail with limitations that can be enforced to the running container using all sorts of quota, CPU quota, RAM quota, hard disk quota, etc. which Docker uses the Linux kernel and uses Linux kernel technologies to provide these quota and sandboxing, etc. Docker uses a system of overlaid file systems, one on top of each other, and these file systems usually come from OCI images, which you can download from hub.dockerhub.com and from other Linux container registries. And on hub.docker.com you can also see OCI images which don't use the Linux kernel. For instance, there are Windows Docker images. Okay, so such a container repository website is now this one, download.freebsd.org/releases/OCI-images 14.2-release. And an alternative to the Docker software is the Podman software with its suite of other software. So there's in fact 3 software pieces. There's Podman, there's Build.ah, and then there's Scopeo. All of these 3 softwares are packaged for FreeBSD and are grouped together into a FreeBSD meta package named Podman-suite. Okay, so Podman runs containers, Scopeo downloads container images, and Build.ah is support for converting plain text files named Docker file or container file into container images. Okay, I've searched on Google for FreeBSD 14.2 container, and I got to this very important blog post from DCH, people.freebsd.org/DCH. In here, there's a tutorial, a very recent one, 4th of December this year, on how you can use the FreeBSD 14.2 release and how you can run FreeBSD containers. I also have instructions on how I managed to install the Podman suite on FreeBSD 14.2 and how I got to have some containers running, including the Alpine Linux container. Okay, let's this is the one. Let's look first at the packages which are available on FreeBSD 14.2. So we know there's 3 packages. So Podman depends on Conmon, which is, I'm not sure what, connection manager, container monitor, something like that. Container networking plugins, container common, and OCI jail. So the engine, which bridges FreeBSD native technologies and Docker style technologies, is probably this piece of software, OCI jail, because FreeBSD can natively run FreeBSD jails, which is something similar to a I don't know, a OpenVZ, Virtuoso, Linux chroot, and other Linux containerization technologies for system containerization, not for application containerization, such as LXD, Inculus, LXC, etc. So let's not install, and let's look what the other 2 packages, what are the dependencies of the other 2 packages. Build.ah depends on the some of the same packages. So container networking, containers common, and OCI jail. And then the final one, which is Scopeo, depends on containers common. And then if we do package search for Podman, we can see that there's this helper meta package podman-suit, which is a meta port, which contains Podman, build AH, but also Scopeo. So instead of installing the three software packages individually, I'm going to install Podman suit. Maybe, I don't know, in the future, some additional packages will be added to Podman suit, which will not be added to these three ones. Okay, so the three packages, build AH, Podman, and Scopeo, the meta package on top of them, and then the dependencies, conmon, container networking plugins, containers common OCI jail. I agree. Eight binary packages to download and install. And a ton of package messages. We will need to save somewhere the messages from these FreeBSD packages. So let's do that. Package messages. Let's start reading from the package messages because these are authoritative. These are the canonical information, whereas the wiki page might not be as up to date as the package messages. So it says that containers common. If I'm using ZFS, I'm not using ZFS, I'm using the alternative, which is UFS, which says in here, if I don't use ZFS, then I don't want to use the driver ZFS, I want to use the driver VFS, probably for a virtual file system. So I'll need to run this command. Let me look at my messages. Yes, that's what I did. So we're going to run this command. How do we split things? I have installed FreeBSD 14.2. I have enabled sudo. The only user is named administrator, which is a sudoer. And I have installed KDE Plasma 5. After that is this current recording. I'm just installing software. I'm configuring Podman, etc. Okay, so we're at this line, which should have, because I have installed the package containers common, now the file /usr/local/etc/container/storage.conf starts existing, so we can edit it. Let's eventually look at it. Okay. Next up, the next package message, conmon, says that I should mount the dev file descriptor file system, and I should run this thing whenever I restart the computer, or I could edit /etc/fstab, so I'll do that. Let's see if we have nano installed. No. Yes. Okay, nano /etc/fstab. I have procfs because that's required by KDE Plasma 5. Ctrl-Shift-V. Trailing new line, fdesk/dev/fd, fdeskfs, read write 00. Okay, Ctrl-X, Y, enter. And now, in order not to restart the computer, to have the operating system mounted, the file system mounted, I could run this command, or probably mount -a. Okay, I did that. Next up. Okay, here it comes. The operating system FreeBSD will provide networking to the containers, to Docker, but that's done using NAT, which is Network Address Translation, which means that we need to have a PF firewall, which will do the NAT. Currently, we don't have a PF configuration file. I'm not even sure if the PF module is loaded into kernel mode or if the PF service is running or installed, etc. It says that I should create /etc/pf.conf using this command line. I'm going to copy it from /usr/local/etc container/pf.conf.sample. Then it says that I should edit the new file and put my correct network interfaces there. Let's see what network interfaces I have. Just one, it's called VNet 0. Okay. Let's edit the configuration file. And in egress interface and v6 egress interface says IX0, which I'm actually going to replace with VTNet. Ctrl-Shift-V. I'm also going to just disable IPv6. I have never used IPv6. I'm not sure how to use it. I'm not sure my internet service provider likes such a thing, so no IPv6. Ctrl X and Y. Okay, so this will create two new network interface cards on the FreeBSD operating system, which provide the networking for the jails and for the containers and for Docker, etc. Okay, next up, it says that I should enable PF. I should start PF. There's support for communication between the container host and the container guest. I'm going to actually do what it says in here. So /boot/loader.conf is empty. I'm going to add pf_load yes. trailing new line, Control X, Y, Enter. Then I'm going to load the kernel space module, which is already loaded. And then restart the service PF. Okay, then it says that I should look inside /etc/pf.conf. And it should contain the line net minus anchor space double quote CNI minus RDR / asterisk double quote. Next up, it says how a Docker, whatever, container instance that's running might serve, for instance, an HTTPS server over the default HTTPS TCP port, which is 443, but that you can expose to the host using the Podman command line, for instance, on port 1234. And then this is an example on how you can exercise that port that's used for a HTTPS server that's listening to the HTTPS port on inside the running container instance. Okay, and then for build AH, which is used for converting Docker files to container images, is experimental. Okay, for Podman, this is the simplest example on how you can run a FreeBSD container. So not a Linux container, but a FreeBSD container. I'm not sure if this thing exists. We can check. Then it says that we can mark a container instance to be restarted when the computer restarts, when the FreeBSD host operating system is restarted, which is this one. sysrc podman -enable yes. And then mark the a running instance with -+ restart equals always. Podman on FreeBSD allows you to run both FreeBSD container images, but also Linux container images. It's not really clear how that would work because container images for Docker don't actually contain a kernel. And that's actually possible because the FreeBSD kernel has functionality to emulate the Linux kernel syscalls. So these are the command lines that are relevant for enabling the Linux support in the FreeBSD kernel and then running using Podman a Linux container. Pay attention to this command line parameter --os equals Linux. Okay, and then there's also cross-platform images. Okay, so that's about it. Let's see. Okay, let's look now at the wiki page, what it says. So there's two container images. Static is really small. We've talked about it. The next one is dynamic, the middle one. And then minimal also contains Unix style command line executables. Scratch is needed when you use build AH in order to start with an extremely minimal container. The three executables that we talked about, I have integrated the changes from /usr/local/etc containers/pf.conf.sample to /etc.pf.conf because I just copied it. This /etc/pf.conf file did not exist before. I've edited fs tab to mount file description file system. I have installed Podman suite. I'm not going to use non-AMD64 container images. I have switched from ZFS to UFS to VFS. There's configuration files. An important one is this one, registries.conf.sample. You might want to edit your registries.conf file such that it gives priority to the containers from Docker Hub. I'm only going to use AMD64. I'm not going to use ARM64. Let's run these commands from here. Let's see what they do. In here. So in here, it will use the URL that we expect where the three FreeBSD container images exist. Then it's going to fetch, so an operation similar to git clone. It's going to download the minimal.txz file. The minimal is actually the largest of the three. We can see that it contains 3 blobs. Then we're going to fetch the middle image, which is the dynamic one. Contains just 2 blobs and both have been already downloaded. So these 3 blobs are 9 is probably dynamic, 3 is probably static, and 6C is probably minimal. Okay, and then the last one, the static, contains just blob 3D and already downloaded, already exists, which is this one and this one. And dynamic is 915, which is this one. Okay, we can list the images in 2 ways. The command line for Docker would be Docker images, but in Docker, you can run all of the Docker commands when you're running as the Linux user root, or there's the possibility of adding your special non-root Linux user to some user groups and giving that user some additional permissions such that you don't have to prepend sudo to all of your commands. But in FreeBSD, I just have switched to the user root and I'm running all of the commands without any sudo in front. But even in here, you could run sudo and it will work correctly. It will be a no op. Okay, let's see Podman images. Let's see build AH images. So we have 3 images which are coming from the repository localhost, not from download.freebsd.org. The tag is the version and CPU architecture, ISA, instruction set architecture. The minimal, dynamic, static. You can also look at the size. The smallest is 6 megabytes. The medium one is 16 megabytes and the larger one is 35 megabytes. You will most certainly start with the minimal one, and you might go even smaller than the minimal one. But I know in 90% of cases where you're going to actually use a FreeBSD userland inside of the FreeBSD container and not a Linux container, you're probably going to go with this image, FreeBSD 14 minimal. But somehow you need to make sure that the image is fetched each time in order to make sure that you have the latest updates and FreeBSD base packages, patches, security updates, etc. Okay, let's look at this thing with layers, which is interesting. So the command line says podman image 3 for the one which contains 3 layers, which is the largest one, minimal. Contains 3 layers. The 6 megabytes is static, the 10 megabytes is dynamic, and the 19 megabytes is minimal. In total should be 35 megabytes. Okay, and then we can actually inspect something like a source code for the container image. Let's look what it shows in here. So it says that we're using VFS, not ZFS for storage. That there are 3 layers, as we talked about, the static, and then on top of it dynamic, and then on top of that minimal. It was created with build AH. Again, build AH is experimental. And these are the entry points of the 3 layers. Okay, what's next? And we're finally going to enter a FreeBSD container. So we're going to do something similar to the hello world. I don't know, not the hello world, but the second example that you usually do when you learn Docker. The first one is you run the Docker hello world container, which just prints something at standard output. But this is the next step, which is probably, I don't know, the Ubuntu container, and then you enter it with /bin/bash. It's similar, so run -it. So that means it's going to create a TTY and connect to it. We'll get this instance of the command line shell, which is bash in my case, get to connect to the standard input, standard output, standard error streams of the process that we're going to start inside the container. Bash is not available in FreeBSD base and not available in FreeBSD minimal. So we're going to use what's available there, which is sh. And that's it. We're inside the container now. How we can see we're inside the container, the prompt does not come from bash, but from sh. PS says that just one process is running, /bin/sh. What else can we do in here? You name -a prints data about the running FreeBSD kernel. Okay, let's see if we have 3 in here. Nope. The number of command line executables is extremely limited. We can look at some of these. So this is the slash. Slash bin contains minimal files, need whatever the minimum executables available in this image are the ones that you would expect, such that sh POSIX style scripts work, and that requires square parentheses, for instance. If that's not built-in inside of the current shell, which is sh. This is the shell sh /bin/sh ps link listing contents of directories, creating symlinks, line editor, copy files, change mode, list file contents, sleep used in scripts, delete directory, what's the current directory, pwd, who am I? D for copying, df for disk free. Okay, /sbin. In here we have mount. The message, the checksum executables, fscheck alt power off. Okay, so /bin/sbin /usr/bin and /usr/sbin /usr/local is empty, as you would expect, because the minimal container FreeBSD image contains just parts of the FreeBSD base tarball, binary tarball. Okay, let's try to install software in here. How do we do that? Package, install. What can we install? wget says that pkg has not been installed yet. It fails because this file does not exist. 404 not found. We can work around this by switching from base release 2, which is 14.2 latest, to quarterly. Let's look at my notes. So that's a sed. And then rerun the package command line. Yes. And now we enter this issue where the net in FreeBSD is not great, and at least in my case, which is I'm running a hardware computer, on top of it I have a Linux operating system, which is Ubuntu 24.10. On top of it I have a QEMU KVM virtual machine, which is what you're seeing here, which is the FreeBSD. operating system, and then on top of it I have the FreeBSD container that's using NAT. So PF and NAT are creating this issue where I have issues related to ALRO, TSO, the package length, and MTU. We can see that by looking at the speed of the file that's downloading right now, which is this one. What am I doing wrong? FreeBSD 14, AMD 64, quarterly, yes. So the speed is extremely small. I have 1 gigabit internet connection in here, and the speeds are around 1 kilobyte per second, if that. And that's because there's ICMP package loss with NAT. Network address translation. Okay, and the fix in here is to run this magic command, which disables ALRO and TSO for the current network interface card. Okay, back to where we were. Let's start the container. Let's try to install software. It says that it cannot, that it wants to fetch. It says that latest does not work. I should switch again to quarterly. And now package install wget again. And this time download speeds are normal. It downloads the pkg.pkg file, the other one, pkg.txz file, installs pkg, the FreeBSD package manager. And then, probably because I have switched to quarterly, it will try to install it installs ports which are built as binary packages, so it does what it should. Okay, how do we test this thing? So index.html, how can we visualize this thing? I don't know. Package install vi. Vi, vim. Yes. I'm not sure if text user interface applications work correctly because we're inside of a terminal emulator, which is console, which has inside bash, which has inside podman-it, etc. But we could try. And it does work. So text user interface applications do work correctly. I have vim, not vi. Vi is, as far as I remember, is part of FreeBSD base, but it's maybe not available via PKG. Okay. And that would be it. Next up, you would want to install a HTTP server, probably Nginx or Apache HTTPD. Using the Podman command line, you would want to export the port 80 or the HTTPS port from the running container instance towards the local host, towards the FreeBSD host operating system. Let's see the list of running containers. We have one running container named Reverend Tesla. Images. 3 container images. So next steps would be to expose a useful service from the container towards the host, and then you would want to not have an extremely long Podman command line, and you would want to use a container file or a Docker file. Okay, let's see that Linux containers actually work, and then that will be it. Let's see Python. Yes. I'm not sure what this thing is doing. Okay, the correct Python version was either already available, which I don't think, or it came with this package. The default version of Python that's shipped with FreeBSD 14.2 is Python 3.11, and now we just have it available. At least the part with batteries included, so the command line interpreter and the standard library. Let's do this very complicated print thing. So we're hello. So we're inside Python process, which is inside a FreeBSD container running. That's inside a FreeBSD operating system 14.2, which is inside a QEMU VM, which is inside Ubuntu 24.10, which is actually running on a hardware computer. Yay. Control D. Control D. And we're back. And now if we're going to run if we want to list the running containers, there's 0. And the ones that have run previously are the Reverend Tesla and the Frosty Cartwright. Let's see the Alpine container. The example from the package messages says that you should run the following command lines. So sysrc Linux enable yes. Start the Linux service. And then we're going to run this command line. Now it complains that there's not enough containers defined in /usr/local/etc/containers/registry.conf. And we're going to work around this by qualifying a bit better this Alpine. And we do that by prepending docker.io/ in front of it. Okay. Control left and right works because I'm using bash. Docker.io/. And now it's git fetching, git cloning, whatever, downloading the overlays. There's at least the overlay 3.8a. And this is the actual result of the cat command. And head -1, we can eventually remove the head and see the entire /etc/os -release from inside a Linux container that's running, and that has the Alpine image inside. Okay, for extra exploration inside the Linux container, we're going to not run the cat command, but we're going to start an interactive session. So that means -it, this interactive and then connectivity-wise. And we're going to run /bin/sh. I'm not sure what shell, command line shell is default inside Alpine. I'm going to guess that they're not so fond on the GNU project, so not GNU bash. And that's it. PS AUX, it's actually BusyBox /bin/sh. But this container has way more command line executables than the minimal FreeBSD 14 container image. For instance, the FreeBSD minimal did not have 3, whereas this one does have. As you would expect, /bin is full with executables which are just symlinks to /bin/busybox. That's the way busybox works. What else? /etc. There's a /etc/os -release. /home empty. /proc, huge one. /sbin, the same thing, symlinks to /bin/busybox. The sysfs. /usr/bin, the same thing, symlinks to /bin/busybox. /lib contains probably OpenSSL. /sbin symlinks to /bin/busybox. And that's about it. Very minimal container image, but because BusyBox offers by default only one executable, which is as statically linked as possible, but then it has symlinks towards the BusyBox executable from 10,000 command line executables from the minimal Unix userland, then yeah, we have more command lines available in the minimal Alpine image available than the number of command line executables that we have available in the FreeBSD 14.2 minimal image. And this concludes. We have seen how to, on a fresh installation of FreeBSD 14.2, how to install all of the needed packages and configurations such that Podman suit works correctly. The three executables Podman, build AH, and Scopeo. We have managed to download container images both from this URL, download.freebsd.org releases OCI images, but also from Docker Hub. That's where we got the Alpine image. We were able to run two containers, the FreeBSD 14.2 minimal one and the Alpine one. The Alpine one uses the FreeBSD kernel mode Linux emulation. Both images work correctly. The only issues that I have encountered in here are the fact that I'm forced to switch to the FreeBSD quarterly PKG inside the FreeBSD minimal container instance, and the fact that I needed to disable ALRO and TSO in order to have normal internet speeds inside the FreeBSD running container instance. Thank you.